Alright, in this video I'm going to do an example of alpha decay and an example of beta decay. So we're going to start with the alpha decay. I already put uranium-238 in here. So remember that this bottom number right here is the number of protons. This top number is your protons plus your neutrons. When you're looking to identify the element on the periodic table, make sure you always use this bottom number, never the top. To do this, we have to kind of treat it just like math class. Law of conservation of mass says the total mass on the left side of the equation, which is this part right here, the 238, has to equal the total mass on this side of the equation. So if it's an alpha decay, from the last video, I went over it, you can put in your alpha particle. That's going to be something. So what you have to look at is that 4 plus something has to equal 238. So 4 plus 234 will equal 238. So just pretend that arrow is an equal sign. 238 equals 4 plus 234. The bottom works the same way. Treat it like an equal sign. So 92 has to equal 2 plus some number. So that some number will be 90. We're going to look at this bottom number right here to identify the element on the periodic table, which comes out to be TH for thorium. That's your alpha decay. So notice that an alpha particle changes the mass by 4 and atomic number by 2. So what I mean is that top number right here changed by a value of 4. And this bottom number right here changed in the value of 2. Okay, so now we'll look at beta decay. So this is cobalt-59. Same thing, bottom number is protons, top number is protons plus neutrons. Here's your beta particle. Same thing, this arrow is an equal sign. So 59 equals 0 plus some number. Well, in this case, it's going to be 59, because 0 plus 59 gives me 59. Now the bottom gets a little tricky, because 27 has to equal -1 plus some number. So this is where it's actually 28. So it went up a number. And then you match that 28 to the periodic table, and it happens to be nickel. So notice that in a beta decay, the mass doesn't change, but the atomic number changed by 1. So your atomic number changes by 1. Now with a gamma again is 0 over 0 with the gamma particle. So if it's just giving off gamma, it actually doesn't change its protons or neutrons. And rarely ever does gamma come away from a particle on its own, because the whole point of giving off an alpha, beta, or gamma is to change that proton-neutron ratio. So if it's giving off just gamma, that doesn't change anything. So normally gamma comes off with an alpha or a beta, and it'd be written like this, with just the gamma off to the side. But you're not going to be tested on that, so don't stress about it. And that's your alpha and beta decay.